Shri Guruvyo Namaha. The last session we had discussed about the consumer equilibrium, how he is getting equilibrium in single commodity and two commodity cases. Okay, now shall we go for a recap on the presentation of data in statistics. So how the data can be presented. So it has been presented in three methods: textual, tabular and graphical method. Textual method, we already know that, which comes in a paragraph or a sentence. Okay, the information which we use to write it in a continuous matter, that is called as the textual. And the tabulation we have discussed what a good table should consist of. Clear? You can see in the slides what a good table should consist of: title, column headings, captions, table number, what is the sources of the table, what is the body of the table it contains, what the column heading it represents, the date of the column, and what are the row designations. So everything will be mentioned in the table. So it helps us to understand the information for what purpose a table has been created. Clear? The next we'll go for the diagrammatic representations. So these representations will be take form in the form of geometric frequency diagram and arithmetic line graph. Okay, so geometric diagram, how it will take place means simple bar diagram, multiple bar diagram and component bar diagram. Okay, in simple bar diagram we can know it is where it comprises of equispaced and equi with rectangle bars for each classes of the category. So for each classes you can see the what is a category which is represented in this slide. Clear? And the next one is multiple bar diagram, which helps to compare the two or more sets of data. For example, what it is given here: platinum, alpha and deluxe. So between these things, platinum, alpha and deluxe, they can able to compare the productions or distributions or the manufacturing what is taken places in the different years. So multiple bar diagram helpful for using the comparing between the sets of data what we have been formed. Okay, the next one is component bar diagram. It is component bar diagram. It shows how the bar has its subdivisions into two or more components. It is also called as the subdivided bar diagrams or subdiagrams. So it helps to construct bar diagrams on the x-axis and also in the y-axis how we are constructing the normal bar diagram. Okay, so each and every information will represented in the single column, single bar. So here you can see that the represented of the boys and girls in this each and every category. Okay, so this component bar will be helpful, same like comparing the size of different components. The next one is pie chart. So you already know how to draw a pie chart. So it is a circle where the area has been proportionally divided among the components. So we already know that the circle will has the 360 degrees. So whatever the pie chart, the information it contains, it has been equally divided. Okay, so it is divided equally as many parts as the components by drawing a straight line from the center of the pie diagram. So here you can see the calculation is given how to find out the percentage, that is the value of a component, by the total value of the all components into 100. How we are finding out means the question will be given all these things, so we have to add together. If we adding means we will get the total. So each and every individuals we have to divide by total into 100. Why we are multiplying into 100 means to find out the percentage. Okay, so what the value what we are getting, that we have to multiply with the 3.6 degree. How we are getting 3.6 degree means 360 by 100. Why this 360 means because the circle will be always is contained the 360 degree. So whatever the parts we are dividing in the pie charts, all should have the equal components. For that purpose we are dividing with the 3.6 degree. So whatever the value comes, based on that we can proportionally divided the information. So it is given in this pie chart. Okay, so marginal worker, what is the percentage of marginal worker, main worker and the non-worker. The next one is frequency diagram. So frequency diagrams, under this we are going to see what is histogram. So histogram has the two-dimensional curve. Here there is a difference in the bar diagram and the histogram. So bar diagram, the gaps will be there between the two bars, where in the histogram the gaps will not be there, continuously it will be have. Okay, it is a set of rectangles with the base of intervals between the class boundaries, where the area is proportional to the class frequencies. So if the classes are not continuous, they are first converted into continuous classes. When there is a difference in the class intervals, then it will be converted into continuous class intervals. So how we will convert it, we have seen in the class itself, that is 0.5 will be added in the upper limit and 0.5 will be reduced in the lower limit. Okay, so here based on this tabular column, the bar diagram, that means the histogram has been drawn. So here in the diagram itself we can see the differences in the bar diagram and also in the histogram. See, there is no space between the bars. Okay, so that shows the histogram. Then unequal class intervals. See, here you can see there prevails an unequal class interval, that is 49 to 45. So suppose if any variables comes between 49 and 50, means how we will calculate? That means in 49, that is upper class limit 49, 0.5 will be added, where in case of 45, 0.5 will be reduced. So what value we will get? It means 44.5 and 49.5. Again the 49.5 and 54.5. So 0.5 will be differ in each classes. So after we are converting into the equal class intervals, we used to draw the curve. Okay. The next one is frequency polygons. A frequency polygon is a straight lines which is usually for 4 or more lines. Here in this frequency polygon, it is alternative to the histogram. That polygon is derived from the histogram itself. So here we can see the polygon, frequency polygon is nothing but the black line which forms here, that is the frequency polygon. So frequency polygon can be drawn without using the histogram also. So frequency polygon is an alternative used to histogram. So first we have to find out the midpoints of the class intervals, and then we have to mark the frequency polygon. See, here in the given diagram you can see how the points has been marked. Okay, so what is the midpoint of this whatever the tabular column it is given, from the class intervals we have to find out the midpoint. For the midpoint and the class interval we used to draw the frequency curve. And the last one we are going to see the Ogive curve. Ogive curve is obtained by plotting the graph and the cumulative frequencies. In this two type of frequencies are there, less than cumulative frequency and more than cumulative frequency. So here in this tabular column you can understand how to find out the less than and more than frequency curve. So the class interval has been given 0 to 20, 20 to 40, like this it goes 80 to 100, and the number of students is given here. So how we will find out the less than frequency curve means, so the normal, the first number of students what it is given, it will be entered as a first frequency curve, that is in less than cumulative frequency, and the next we will add it to the next line what it is given, that is 5. So the 6 plus 5 will gives you the 11, 11 plus 33 gives you 44, and 44 plus 14 gives you 58, 58 plus 6 gives you 64. So the total is 64. Okay, so that total will be comes here as the more than frequency curve. With this what we will do, we will minus this 64 minus, wait a minute. Okay, now we can see in this 64 minus 6 will be getting the 58. Okay, again this 58 minus 5, 58 minus 5 will gets the 53, 53 minus 33 gives you the 20, 20 minus 14 gives you 6. Okay, then it will be equally balanced. So okay, this is the way you have to find out the less than and the more than cumulative frequencies. So after forming this, we can plot a point on the graph and we can get a curve like curve, that is this is a less than frequency curve and this one is the more than frequency curve. So when we are joined together, we will get the curve like this. The point which is intersecting, okay, the point which is intersecting will be considered as a median. So from the frequency less than frequency and more than frequency, we can able to obtain the median. Okay, the next one is time series. So with the given informations we can able to draw the curve, the plotted we can be mark whatever the information is given. So in the time graph series we can able to mark 2 or 3 information in a single graph. Okay, that is called as the time series. Clear? So I think you will be clear with this, how to construct a pie chart and how to draw the histogram and how to draw a frequency polygon curve and how to find out the median by using the less than and the more than cumulative frequency. Thank you children.